Okie dokie, hello everyone. Today in this video I'm going to be doing the walkthrough solution for assignment number 4, okay, for the How to Program with Java blog or the Java Video Tutorials assignment series. So this is assignment 4 and this is all about the anagram solver, okay? So the anagram, as I'm sure you're aware, as you've hopefully gone through and tried this assignment out for yourself, an anagram is essentially any two words that can be made by shuffling around the letters of the first word. So you can take, cloud and shuffle letters around to make the word could. Okay, so that would constitute an anagram. So let's so we have this interface here that I've created. It defines one contract, which is any class implementing the anagram solver must have the is an anagram method that'll return true or false on the basis that the two strings passed in do or do not constitute an anagram. So we have this public boolean is an anagram method that takes two parameters, word1 and word2, as strings, which are both the potential anagrams, and it will return true or false based on if it's an anagram or not. So I also have the anagram solver implementation here, and I'm realizing now that I'm missing the tests. So let me just take a second and get the tests class file in here. Okay, we're back in business now. I just grabbed the tests Java file. It was just missing from my computer, but I double-checked the actual assignment online, and it did indeed exist there, so all is well. So the trick here is going to be I need to actually create the code inside of the anagram solver implementation. And I have also a tests file where I can run these tests to determine if my code is indeed working or not. All right. So the first thing you see here is you'll need to implement some code here to get these tests working. And I did that because I didn't have this public class anagram solver impl. I don't have, and I purposely did this, the line implements anagram solver. Okay, I wanted to make sure you guys really understand the fact that with the use of interfaces and inheritance here, that it's necessary when you have something that is named anagram solver impl. The impl part is the convention that we use to say that this is the implementation of an interface, and usually the convention is that the name will suggest what the file is that it is actually implementing. So you see here anagram solver matches anagram solver.java. So that's sort of the hint about what file you should be using. So if I don't have this implements and I go into my tests here and I write in the code that I need to have, I expected you to say system under test equals new anagram solver impl. But to do that, it would give you an error because there's a type mismatch. Anagram solver impl right now is not of the type anagram solver, and that is precisely because of the missing implements anagram solver. So as soon as you put this in here, implements anagram solver, and then you actually add the unimplemented method inside, then you can go back to your tests and this is now working properly. So that was the reason why I didn't include this line here, because there would be a compilation error, and I didn't want to have any compilation errors. So hopefully you're able to put all that together, and if you didn't, then there you go. Now maybe you could pause this video, go and implement exactly what I did, and try to actually solve this assignment on your own. All right. So now what I've done here is I implemented the anagram solver, and therefore I needed to override the is an anagram method, which again comes from anagram solver. Okay, is an anagram. This is the interface that defines the contract of the is an anagram method. So I've overridden it, it's just there's a default implementation that gets generated that just says, return false. So if I try to run my tests, you'll see that not all of them pass. Okay, so it's funny that you have what is this, 4 out of 6 pass, and all I have here is just return false. So you might think that you're almost there already, but it's actually not the case. It's just these tests are expecting a false value, so it just happened to work out. All right, so let's start with the first test here. The first test says we should return false with 2 null values. So if you pass in a null, then there's nothing we can do. If there's a null, then clearly there's no way that we can compare if a word is an anagram when you compare it against null. Okay, because null means nothing. It means void, empty. So we should expect that when we implement our code, we should handle the null case. So let's go ahead and do that. Let's implement our code that will handle the nulls. So here we can say if word1 or word2, if word1 equals null or word2 equals null, then just return false. Okay, so that's probably what I would do. So in the case that either of them are have the value of null, then we just return false, and we're happy. So let me just change this to true now and see how that all plays out in here. Hopefully I don't trick all of my tests. Okay, good. So stuff still fails. Cool. So I think that pretty much should handle the first test case here, that we should return false if there are any nulls. And also the second one is we should return false with just 1 null value as well. And I'm handling that because, if word 1 is null or if word 2 is null, because this space here would represent word 2, because we're inside of the parenthesis here for the is an anagram method. If this was null, then we'd also get a returning false because of the if statement that I created. So let's go down into this third one, and it says that if we pass in these 2 different words, tool and tools, that the resulting Boolean should be false because we have 2 words that are different lengths. So here, what I would probably do is I'd have this shortcut condition statement that would check to see if the 2 words are the same length or not. Because if they're not the same length, then it doesn't matter what the output is. We know that they are not going to constitute an anagram. You can't have an anagram with 2 words that are of differing length. So I will just immediately, following my null check, I will also say if word 1's length, so I say word 1.length, is not equal to word 2.length, then same thing, return false. Okay, so that'll also handle the test here where it should return false if the 2 words are differing lengths. So let me run all my tests and make sure the first 3 are still passing, and they are. So now we go to the fourth one. And the fourth one says it should handle duplicate letters. So here we have the word tool and the word toll, which when you look at them, they are not. It's not an anagram, right? You can't shuffle the letters of the word tool around to make the word toll. So, and this is really the big stumbling block for most people's coded solution, because most people will likely implement a method that has 2 different for loops. So let me go through. I'm going to go through this assignment and solve it in a way that will probably duplicate what most people actually went and did in the first place, and then they hit the stumbling block where they realize that their algorithm doesn't handle this particular situation. So let me just go into it knowing that this is going to be the wrong solution, and then I'll show you how I would go about fixing it. So most people would think, okay, I'm going to compare two words. So let's say I have, the word cloud and the word could. So what I'll do is I will go through each letter of this first word and see if that letter exists in the second word. Okay, so I start with C, I check the second word, and yes, C exists, so we're still good. Then I check the L and see if the L exists. We scan, and then boom, we see an L. Okay, we're good. We have the O, we scan, okay, we have an O, so we're good, and so on and so forth. And if we can go through each of these letters then and find them in the other word, then we're happy, then we have an anagram. So how would you go about implementing that particular solution? Well, I'd probably have two for loops, okay? So the outer for loop would iterate through each letter of the first word, okay? So how would I do that? Well, I'd probably start with my integer I, and starting with the 0, and I would go to the length of the first word, okay, and I would be incrementing by 1, okay, and then I would look at the actual character at that particular spot. So I would probably do word1 dot char at, and char at is nice because it returns the character value. So the individual letter at the specified index, okay? And the index ranges from 0 to length -1. Oh, that's a good point. Should I do length -1? No, I shouldn't, because I'm doing less than here, so that'll already be length -1. So yeah, I'm going to use char at, and the index will be I, okay? So what happens here is the first time through the loop, this will return C, and the second time through the loop, this will return L, third time it'll return O, fourth would be U, and fifth would be D, okay? So that's nice. And we can assign this to a variable. So this returns a character, okay? A primitive type character. So I will have to implement a character variable. So let's just say word1 letter, okay? So I will store that, and then I want to compare this letter to the letters in the second word. So how would I do that? Well, I would iterate through every single letter of the second word. So I would do another loop. This time I'm going to use J as my index. J minus, or less than word2 dot length, J plus plus. Okay, so you see how that would increment through every single letter of word 2. And I would do the exact same thing. I would create a char, and I would say word2 letter equals word2 dot char at index J, because I'm iterating through J here. And then that would grab the actual letter for word 2, and then I could just compare word 1 letter to word 2 letter. So I could say if word 1 letter equals word 2 letter, then I would have some sort of situation where I know that these two characters match, so I could continue through my loop, okay? So how would I do this? The first thing I would do is probably have some sort of Boolean variable to indicate that everything is okay. So how would I do this? I would probably start with some sort of Boolean that says is an anagram, and I would initialize it with what value? Let's see. I could initialize it as, how would I do that? False? See, it's funny. I didn't actually solve this this problem using this method. So what you're hearing and seeing right now is my actual brain chugging through exactly how I would go about solving this problem. Let me just leave it as false and start programming through and seeing how it all turns out. So what would I do here? If these two letters are equivalent, then we know that we possibly have an anagram. So I would say, how would I do that? It's almost like I would want to I want to have a Boolean variable inside of my first for loop that would be checking each time to see if we have a letter match. So let me say, has a letter match, and I'll start it with false, and then I would set this to be true when I have a letter match. Okay, and then here I'd probably want to break out of my inner for loop. So if I put a break statement here, it will stop iterating through the inner for loop, because when I start my outer for loop and I grab the first character, which is C, and then I compare it to the first character of the inner for loop, which is here, and it's going to go through the second letter or second word. If I find a match right away, then why would I continue looking, right? So as soon as I find a match, I want to stop because I found a letter match, so everything is good. So that's why I use the break statement. When you put a break statement, it will break out of the for loop or the loop in general that that the break is contained inside of. So that'll break out of this for loop and stop doing everything. So since we have a letter match, it'll go out and then we can say if we don't have a letter match, so if we couldn't find it, then we know that we can return false, right? Because if we didn't find any matching letters, then we clearly don't have an anagram. Okay, so then it would go back to the beginning of the, well, if it didn't find a letter match, then it would return false and break out of the loops and it would be fine. If we did find a letter match, then it would go back to the beginning of this for loop, grab the next letter, initialize this variable again to be false, and then search through the inner for loop again and go through the same thing and hopefully find a letter match, and then blah, 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 blah. So if we can get through this entire for loop and never return false, then I believe we have found ourselves an anagram. Okay? So if I were to go and run this algorithm, what would happen? Okay, so two things happen here. So the duplicate letter test fails and the uppercase lowercase equality fails. So what's this one? Should treat uppercase and lowercase equally. So care and race should be considered an anagram even though they are of differing uppercase and lowercase values. So let's handle that situation. That's fairly simple to solve. We could throw that in at the top and say word1 equals word1 dot to lowercase. Okay, so we're taking the existing value of word1, we're casting it to be a lowercase, and then reassigning it into itself. Okay, so there we go. That should handle that situation. And we do the same thing again to lowercase for the second word. And it should be as easy as that. And then we go back and run our tests. And now we see that the only test that's failing right now is the duplicate letters. So this was the stumbling block that I was talking about. This was a solution that maybe some people would have come up with. And it would work for a lot of the anagrams out there, but it doesn't work for a negative case, okay? So how do we do this? How do we handle this whole duplicate letter conundrum? Because like you see, our algorithm will go through and it will search for a T and it'll find it. And then it'll search for an O and it will find it. It'll search for an O and it will find it. And it will search for an L and it will find it. And then it will return true. Okay, so that's not good enough. So there's a few different ways that you could go about doing this. One solution is to, as you search through the first word and you find a corresponding match, then you would remove that matched character from the second word. Okay, so if I find T and I search for T and I find it, then okay, I remove the T. And then the next letter is O and I find it and I remove the O. And the next letter is O and now I can't find it, so there you go, it must not be an anagram. And that's a good solution. That would work. If you did it that way, then I commend you. But the route that I chose was slightly different because I like to work with data structures. So my solution is I like to convert what I have here into a map. Okay, so remember that a map is represents a key and a value. So in this case, the key would equal the individual letters. Okay, so in other words, it could be A or B or C or D, etc. And the value in this case would be the actual occurrence, okay, or the count, okay, of the letters themselves. So that's the solution I went with. So what I would have to do then is I would have to take the word and convert this into its corresponding map of key and values. So for example, the map that I would create here would be, let's see, it would have T as a key, and there would be only one occurrence of the letter T. And then I would have O as a key, because the O occurs in here, and that would occur 2 times because there's 2 O's. And then I would store the letter L in there, and I would have the occurrence as 1. So that's sort of my map representation of the word tool. And then I would do it again, okay? And I would compare it to the second structure, the second word. So I do the same thing. I have a T, and that occurs 1 time, right? Only 1 T. So far it's matching and everything's good. Now I go to O, and I have O, but I see that O only occurs 1 time. So here we don't have a match, and we would know immediately that we could stop and we're done. Or you could just keep going and say, check for L, because L exists and that occurrence is 2. So you see that those are definitely different, okay? And then you would compare the 2 maps, and you'd see that it's not an anagram. So that's the solution I went with. So what I will do here is I will replace everything below here, because everything above here is still useful. I still want to do my null checks, I still want to do my length checks, and I still want to cast to a lower case. But it's my my implementation here that doesn't work, and I want to replace it with this sort of map implementation. All right, so how would I go about doing that? Well, this is where you will have to bear with me once again. The actual solution that I had done for this was quite some time ago now, and of course I've completely forgotten how I actually went about solving this. And I could go and cheat and look at my solution, but I think it's more advantageous for you guys if I were to actually just try and go about doing this naturally, so that you could really see how I go about doing everything with respect to programming. So let's see. The first thing I need to do is create my maps. So I would create a map, and I have to specify what it is I want to store. So I have a key and a value. Like I said, the key will be the actual character value, so I could just use a string. And the value will represent the actual count. And since they're just, whole numbers, I'll just use an integer. And I will call this the word1 map, I guess. And equals new hash map is the implementation that I'll use. Storing a string and an integer. Voila. And I'll use Control-Shift-O to import both the map and the hash map types. When I Control-Shift-O, they get imported up here automatically for me. And I'll do the exact same thing for the word2 map, because I need to convert both of these things into maps, okay? So, the tough part is to take the actual string and break it up in such a way that that it's stored properly in the map. So, I believe I would still need to iterate through the word1. So I'd still have the same sort of for loop. Okay, and oops, I is less than word1.length. And I could probably take the word1.char at index I and assign it into my map. So this is where I would say, okay, take my word1 map, and I would have to say, does it contain this key already? Okay, and the key, like I said, is the letter. Although this returns a character, so maybe it would make more sense for this to be a character type. Let me try that out. Again, I can't remember exactly what I did, a few weeks ago when I solved this, so perhaps I didn't do this, but we'll see what happens. And I want to check and see if it contains this character. So let me assign this character to a variable. Let me call it... actually, let me see if I can store it as a character. So I keep the types consistent, and I just say word1 letter. Okay, can I do that? Yes, I can. And then I will say, does it contain the key of word1 letter? So I'll say if it contains the key, then I need to do something, and if it doesn't contain the key, then I need to do something else. Okay? So if the word1 map already contains this key, then what that means is we've already inserted this letter into the map. So that would sort of be, for this case, I'm iterating through the first word, and I hit the word, or the letter O the second time. So the first time I hit the letter O, it won't contain the key. But the second time I hit it, it will contain the key, so I need to do something. So what do? Well, I need to retrieve this actual value so that I can increment it. Because remember, the first time around, the value is only going to be 1, because it's only, in the word tool, it's only hit the letter O once. So when it hits it the second time, I want to change that to, say, 2. Okay? So what I do is I say word1 map dot get, okay? And when I say get, I'm actually going to get the value based on a key. What's the key that I use? Well, it's the same word1 letter, okay? And that will return me the integer. So if I hover over this, you'll see that it's returning an integer because the map is storing an integer as the value. And when you say get, you're going to get the value based on the key. So now when this returns a value, this is going to be the letter count. Okay? So this is going to be the letter count for the particular letter that we have here, the word1 letter. So what I want to do here is I just want to increment letter count. Okay? I just want to increment it by 1 because I found another letter that's the same one that already exists in this map. And then the most important part is I want to put letter count back into my map. Okay, and how do I do that? Well, I say word1 map dot put this time, and you see that it wants a character as a key and an integer as a value. So I'm going to put my key. What's my key? My word1 letter is my key, right? Because that's the one I've been using since I've started. And what's the value? Well, look at that, letter count. And there you go. So what I'm doing is I'm saying, does the map already contain a key? Since it does in this case, because we're saying if it's true, then I'm grabbing the actual pre-existing letter count that already exists for that particular letter. So if it's an O, it's going to be 1. So that's going to assign this to 1. I'm going to increment 1 to 2. I'm going to increment it by 1. So it becomes 2. And then I'm placing it back on the map with the same letter, which is going to be O, but now with a count of 2. All right, so that's what's going to happen. And now we need to look at our else case. So this is the case when the word map does not contain the key. So if it does not contain the key, that means that we need to insert it. So let's insert it. I need to do word1 map dot put. Okay, so it's the same thing as we did up here. And what are we going to be putting? We're going to be putting word1 letter as our key. And if this letter did not exist before, then it's safe for us to just hard code the value of 1, right? Because if the letter didn't appear before and we found it this time, then obviously it's occurring at least 1 time. So now we place it into the map. And that's good. Now we've created our map for the first word. So now all we really need to do is do this exact same thing again, only this time we use word2. Okay? and we can change, you can change the names of these variables. You can do them the long way, which is selecting this and saying 2, selecting this and saying 2, 2, 2, 2. Okay, that's the sort of low-tech way of doing it, but let me undo everything I just did. And I'll show you. You can right-click on this and say refactor, and you can say, where is it? Rename at the very top. And then it says, enter a new name and press enter. So now when I hit delete, you see it updates all the other ones, and then I put the number 2 in, and it updates all the other ones, and I hit enter. There you go, done. I've now renamed all the other variables safely. So there you go, word 2, it goes from through the length of the word. It will grab the character at the index, assign it to our character here. Okay, so here's word 1 map, so that's clearly not what we want to do. So let's also rename this. Refactor, rename. So we want this to be word 2 map. Oh, but see, it's renaming all of them, so that we can't do that. Let's hit escape and let's control Z that. So unfortunately, it's not that high tech because it can't figure out that I just want to change in the scope of these ones here. So word 2 map contains word 2 letter. Get word 2 letter, assign it to letter count, increment it, and then place it back into the word 2 map. Otherwise, it doesn't contain it, so we put directly onto word 2 map the letter 2. There you go. So now we've gone through 2 for loops to determine or to create our maps. And then what needs to happen? Well, now that we've created our 2 maps, okay, we've created these 2 things, we need to compare them against each other. And how do you do that? Well, believe it or not, it's as easy as saying word1 map dot equals word2 map. I believe anyway, and that should be it. So now if both maps are the same, then the equals will return true because it returns a Boolean. If the 2 maps are different, then it will return false. Okay? So I could actually say Boolean is an anagram equals the result of this equals, and then return that Boolean value. Okay? Or if I want to just skip to the point, I could actually just take this whole equation here, word1 map dot equals, cut, and just actually paste it as the actual return statement itself and get rid of this Boolean variable declaration altogether. So you see how that would return a Boolean value based on this equals. Okay? So let's see if that actually works. Let's go up and run our code. JUnit test, and there you go. All 6 unit tests are now passing. So that's pretty good. I was able to do that on the first run without running into any problems. So I like that. That's impressive. Now you might think, okay, now you're done, and that's fine if you think you are done. If you want to do a little bit of extra credit, I don't like having code that sort of repeats itself. So you see here that we have 2 different for loops, and the only difference between them is this word2 map as well as, this word2 word as well as the word2 map. So what you can actually do, I think you can select the whole for loop, the first one, and I'm not sure if this will work because I haven't done this in a while, but you can say refactor again. This is my friend, refactor, and I can say extract method. Let's see if this works. So it does. It says, okay, now I want to extract a method out of this. And you see how it's smart enough to say, okay, I see that word1 is used in here and word1 map. So what is this? This code will actually become a method now. So I need to give this method a name. So what is it that this code is doing? Okay, it's really just creating a map based on a word, okay, or a string. Okay, that's kind of what this method is going to be doing. And I say okay, and see it completely changed that for loop into a call to this method, and it's passing in word1 and word1 map. And here's the method that it created. It created a private void, create map based on a string method that accepts 2 parameters. One is a string, and 1 is a map. And then here it is. This is my code. So let me structure it so that it's a little bit more easily read. And here's our for loop, and it just goes through the for loop and does its thing. And it's a little bit misleading because the variable wording that it used was to just use word1. But I could actually rename this to just be word, and instead of word1 map, I can just say word map. There you go. So I just did that refactoring thing there with the renaming, and there you go. So now we create a map based on a string, and we do it again. And what it will do is it will actually update our word1 map and our word2 map, and then be able to check and see if those two are equivalent. So you see how we've kind of reduced the amount of code. We now only have this for loop happening once inside of a method, and we just call that method twice with 2 different sets of variables. Okay, so that's called refactoring. That's something that I just did, and I can actually right click on this tests, run as, and JUnit test, and we see that nothing's broken. It's still working exactly as it should work. Okay, so there you go. That is the anagram solver, solved in 2 ways. The first way was not exactly good enough because it didn't handle the case of the double letters, so double O or double L. And then we refactored our solution to be one that takes in the 2 maps and converts each string to be a map with the key as the character, the letter, and the value is the count, the number of times that letter occurs. And then we compare our maps, and if they're equivalent, then we have ourselves an anagram. If they're not, then we don't. All right? Cool. Hopefully that was extremely helpful for you. And well, I guess I look forward to doing the next assignment. So take care, and as always, happy learning, guys.